Welcome to my talk. I'm going to be touching on plugins and how they were developed. I do say that this is a deep dive, but considering the amount of time, this is more of a deep-ish dive. Going to be kind of blasting through a few things, and if you have questions, I'm going to be here to answer questions at the end, as well as just in chat. And if you really want to dive deep, with me or any of the other contributors that have built the plugin framework, you can always join us in Slack, and we'll be happy to talk through whatever you want. All right, let's get started. Spinnaker today consists of over a dozen JVM services. In each of these services, most of the code is non-core integration code, like cloud providers or Jenkins integration, Travis CI, that sort of thing. In the past, getting a contribution into Spinnaker meant either creating a custom build or contributing things directly to the upstream project. When contributing to upstream, not all the contributions really belong in the core product. And there's a lot of process for getting new functionality into Spinnaker. Not all features really need to go through that process. And creating custom builds, it's obviously very powerful because you can do whatever you want, but it's not broadly accessible. Not everyone has the resources or expertise to set up a Spinnaker development environment. We needed a better way for the community to contribute and consume integrations, and for core maintainers to have a path to not maintain all this core code, which we currently do today. So plugins are a new extension methodology for extending Spinnaker. It provides much of the same power that custom builds offer, but without the overhead of setting up a whole bunch of builds and having a development environment and that sort of thing. Plugins today are JVM only, but the extensibility is not really limited to the JVM. There's still the webhook stage, run job stages, and so on that you can extend Spinnaker without having to actually write any like Java. But JVM plugins offer the community a really great way to contribute extensions of all size and complexity today without having to wait for us to build new extension points that might enable, say, calling an RPC service or invoking a Lambda container, that sort of thing. The plugins inside of Spinnaker have two different extension models. There's a stable yet limited scope extension model where we develop strongly typed APIs that have been designed for long-term support. And then there's unsafe but unlimited scope extensions where you are developing against the internal APIs of Spinnaker. So you have a whole lot of flexibility. But on the other hand, since you are developing against internal APIs, there's less stability because internal APIs can change at any time, even inside of like a patch release, for example. So they have a higher chance to break. So how do plugins work? At the core, we use this this library called Pf4j. It stands for Plugin Framework for Java. It's a very lightweight plugin framework used by other JVM services, such as Solar. And it solves the low-level problems of a plugin framework without a whole lot else. It doesn't do nearly as much stuff as, say, what OSGI would do, for example. And we've extended Pf4j quite heavily for Spinnaker so that we can integrate it with Spring, and I'll talk a little bit more about that later. Each plugin is loaded into its own class loader, which is important for providing safety through dependency isolation. You don't want to write a bunch of code that brings in all these different Java dependencies and then sideload that into one of the Spinnaker applications and then potentially overwrite one of the dependencies that the Spinnaker service is using itself. That would tend to make the core Spinnaker product a little bit less unstable and could, in fact, just cause your service to not even start up. Pf4j has three primary models inside of its domain. It's got an extension point, which is what Spinnaker services use to define a contract for an extension. an extension which is written by plugin developers to implement a particular extension, and then a plugin which is a collection of extensions that's packaged up for a single application. Now, since Spinnaker is a product that is consisting of over a dozen JVM services, when adding new functionality, you may need to touch multiple services. It's very common. Like, for example, if you're adding a new stage, you will want to make some code changes to Orca and then also have code changes for Deck, so you can render that stage however you like. Or if you are creating a new cloud operation, wanting to modify Cloud Driver, potentially Orca, and that kind of thing. So you're modifying multiple services. And so we've introduced a concept of plugin bundles, which allow you to build all these plugins, but then package it as a single artifact. This makes development and consumption of plugins much easier because you only need to reason about a single artifact and manage that single artifact rather than distributing out like, this is my very cool plugin for Cloud Driver, but it also depends on my very cool plugin for Orca. So all Spinnaker services are written using Spring Boot. We needed a way for connecting Pf4j, which is a generic framework, into Spring Boot. And while there is an official Pf4j Spring integration, we found its depth quite inadequate for Spinnaker's needs, so we wound up building our own integration. Since our services are written with Spring, we also wanted to offer the awesome power of Spring to our plugins, including configuration, auto wiring, and so on, without necessarily having plugins depend on these Spring dependencies. And the reason for that is, since plugins use a different class loader than the service, if these two artifacts wind up using different bytecode of the same library, the interaction points may cause the service to not start up. And this is just an issue with the JVM. If you have food class and it is running with JVM bytecode version 1, let's say, and then the service is running version 2, it's not going to be bytecode compatible, and so it won't be able to actually talk, even though it is the same class. Internally, a Spring Boot application has an object called an application context, and that is what it uses to store information about the application, including acting as a registry for all the beans inside the application, beans being individual classes, components, that kind of thing, which provide functionality. And these beans are used for dependency auto wiring and that sort of thing. This application context also happens to be tightly coupled to a single class loader. And as a result, each plugin, since it needs to have its own class loader, has its own application context. And this is actually kind of a nice side effect, because each plugin gets to act as its own mini application, as a child application context to the service. So if it requests, say, a bean that the service defines, it will first look in its own application context, find that it doesn't have it, and then go up to the service to get that bean. And that's a really powerful mechanism for being able to depend on certain internal objects that the service provides as an SDK inside your plugin without having to build all that stuff yourself. Doing so allows us to treat each plugin as its own mini embedded application within the service, and being able to perform any of its own isolated auto wiring as well. So you can build up all your classes, and then instead of having to manage all your dependency injection yourself, you can just put an annotation on it of plugin component, and it will figure out how to initialize all those beans itself. Now, when a service starts up, the plugin framework is going to do its initialization pretty much as one of the first things that the service will do. Sorry, let me rephrase that. When a service starts up, the plugin framework is one of the first things that is initialized. There we go. And during initialization, each enabled plugin is first downloaded, if it's not already on the file system, loaded into memory, assuming the checksum passes that's defined inside its metadata manifest, and then it's started. During plugin startup, its application context is first created, its beans are created, and its extensions are what we call promoted into the parent application for auto wiring. Now, this is important. Class loaders and application contexts are unidirectional, so plugins can look up to its parent for dependencies, but the service cannot look down into a plugin to find dependencies. So a plugin needs to explicitly say, hey, I'm going to promote my foo extension and my bar extension, that sort of thing, up into the service so that it can actually use it during initialization. So as a result, plugins are promoting their extensions into the service, and a promotion is just a matter of registering it into the application context for the service. This promotion process makes plugin code available to the service as if it were built into the service itself. And that makes a really nice experience for core contributors because we don't need to reason about whether or not a particular piece of code is provided by a plugin or if it's already provided by the core system. Of course, there's a lot of things that are happening under the covers to make all this happen. And I've documented the internal components and flows that the plugin framework takes, which you can look up on GitHub in the plugin framework code base, which is inside the core repository. In the future, while we consider the plugin framework fundamentally stable and generally available, there's still a lot to do. And this primarily manifests itself in the development or exposure of new extension points across all of our various services. We only have a very limited scope of extension points today. So many plugins that are being developed are opting for the unsafe plugin extension model where they are fully realized Spring plugins. As we get more extension points, these plugins will be able to migrate over to using extension points, and their stability from release to release will be much more assured. As well as developing SDKs as needed to support these extension points. An SDK just obfuscates whatever dependencies are being used to provide a certain piece of functionality. For example, there's an HTTP client SDK that is just interfaces and POJOs, but under the hood, it's being powered by OKHTTP to do all of the actual protocol work. And another example that we are probably going to build soon is a secrets configuration SDK. Right now, if you want to do secrets, it's something that you kind of have to handle, and we'd like to offer that as a baseline library for plugin developers to be able to use. We're also looking at better tooling, for example, auto-generating API documentation for service extension points and that sort of thing. Plugins were developed basically all in 2020 in a joint effort between Netflix and Armory, and I'm really happy to have had that experience building something as large with the group of people at Armory. They were very good, and have been paving the way very well with their development of plugins and really taking ownership and driving direction for extensibility in Spinnaker. It's very exciting to see. Our next big initiative in 2021 with the community's involvement is going to be starting to split out all this integration code into plugins. So you'll start seeing, for example, all the cloud providers will no longer be shipped inside of Spinnaker core. Instead, you will have to install these plugins rather than getting all the cloud providers that you currently do today. And as a side effect, while this will mean setup for Spinnaker will get slightly more involved, the operational aspect of Spinnaker will become easier because the binaries will be much smaller and there will be less code for you to reason about should something go wrong or if you need to add a feature, that kind of thing. Thanks. I know this was a really short talk. I would have loved to have gone deeper. When I originally made this talk, I thought that it was going to be a full hour and I was going to go very, very deep on things. But in lieu of that, you can take a look at these links. I've written a core contributor guide, which dives much deeper into how to extend Spinnaker, as well as some of the gotchas and hard, rough edge cases that the plugin framework has. You can take a look at the plugin framework inside of Cork. It spans basically 3 modules, and if you really want to talk about something and get more details on how the Spinnaker plugin framework was written and how it operates, you can join the plugin Slack, and we will be more than happy to talk with you.